your own. If you haven't, take a moment and do so, and then continue watching to check your work. So in this particular example, we're talking about a food program replacing a soap opera. I know my husband and boys love watching food programming. They're really into street food right now. So here, this is a particular show called The Chew, and it said that according to a 2010 Harris poll, that 50% of Americans watch TV shows about cooking, at least very often or occasionally. We're going to take a random sample of Americans, and we're going to count how many of them watch food-related programming. So X is number that watch in a random sample of 100. All right, so how many are expected to watch food-related programming? Well, if half of the people do and I take a sample of 100, then half of 100 is 50. So in other words, mu, my expected value of n times p, is 100 times 0.5, or 50 people. All right, next one. What's the probability at most 40 watch food-related programming? So probability X at most means less than or equal to. Maximum is 10. 40. At most 40, so max is 40. So 40 or below. This definition, less than or equal to, is the definition of binomial CDF. Okay, so less than or equal to, we're associating with CDF. The previous video, I showed you how to find all this on your calculator. So if you need to go back and refresh, please do that. So binomial CDF, and put in your parameters. Our N is 100, our P is 0.5, and then value we're interested in is 40. And again, the CDF is going to go along with this less than or equal to. And if you've tried that, you're going to get something like 0.0284. Now the next one, probability that more than 40 watch food-related programming. Our calculator doesn't do greater than, and we remembered we can use the complement rule. Greater than is the opposite of less than or equal to, which is what we need for CDF. So this is using the complement rule. Probability of something is equal to 1 minus its opposite. So opposite of 40, more than 40 is less than or equal to 40. Now we're ready to go with our 1 minus binomial CDF, because we have the less than or equal to. We still have n of 100, p of 0.5, and 40 here. And that's just 1 minus our previous answer, so we get 0.9716. The next one should also be pretty familiar. Probability that 40 period blank, exactly that, so probability X is equal to 40. We're going to use binomial PDF. So PDF was for equaling exactly a point. Same inputs, 100, 0.5, and 40. And this is going to give you something like 0.0108. Now the last one's a little bit different from any we've done before. Let's see how much you were able to think outside the box here. Probability at least 75. So probability X is greater than or equal to 75. So you may have thought, okay, this is greater than, I need to flip it around, use the complement rule to be able to use CDF. So you're right on that, but you want to be really careful here. The opposite of 75 or more is going to be strictly less than 75, not less than or equal to, because I cannot include 75 here and in its opposite. So be very careful of that. Notice in our previous example, 40 was not included in the original question, so I needed to include it in the opposite. So down here, 75 is here. I cannot include it in its opposite. So I'm still not set up for CDF, but no worries, we're almost there. Strictly less than 75, since we're counting, would be 74 and below. And now we're ready to go with binomial CDF. Now, depending on your calculator, when you work this out, some of them may display it a little bit differently. I know some people actually get 0 as an answer, but some of you might get something like this, 2.818 times 10 to the negative 7th, or your calculator is going to say e negative 7, but what that means is our times 10 to the negative 7th, or move this decimal right here to the left 7 spots. So the probability is 0.6 zeros and a 2/8. So really small chances of this occurring. Just want to make the comment here, make sure you don't ignore this times 10 to the negative 7th part. If you left that off, you would be telling me that our answer to a probability question is 2.8, which I might draw a little crying face next to, because we're emphasizing this idea probabilities are between 0 and 1, representing 0 to 100% of the time. So it must be between 0 and 1, so don't forget that scientific notation at the end.